Alright, as you can probably tell, the hair is getting crazier every day. God dang it, what is going on? And I can't even cut it. No one in my family is a barber, dude. It's just, if I cut it, okay, it's gonna look worse than how it looks right now. I'm just telling you guys. But anyway, today is a momentous day in the history of the United States, because I am finally done with these APs. God dang it. That was the most, dude, I spent a whole month making AP videos. That was not a good idea. APs are the most brain dead thing in the universe. God dang it. For most people, it just boils down to like cramming on the last day. But Olympiad, now that's where it's all at. Okay, so let us get back on the Olympiad grind. Hello everybody, I'm Karar, and today we are going to finally get back on the fun stuff. Specifically, we are finally going to finish up 2016 AIME 1. God dang, dude. Literally look at this nonsense. I did 1 through 12, and I still haven't done numbers 13 to 15. That is like undoubtedly the worst thing I could have possibly done in the universe. Very impolite of me, I'm sorry. Let's finish it. Sadly, I have not done competitive math in forever, but hopefully I still know how to do stuff. So let's learn about Freddy the Frog. Okay, so he's jumping around on the coordinate plane, searching for a river, which lies on the horizontal line y equals 24. Let's just pretend that's y equals 24. A fence is located on the horizontal line. Oh, another one. Y is equal to 0. Epic. On each jump, Freddy randomly chooses a direction parallel to one of the coordinate axes and moves 1 unit in that direction, pointing at that point where y equals 0 with equal likelihoods. What? With equal likelihoods, he chooses one of the 3 directions where he either jumps parallel to the fence or jumps away from the fence. But he never jumps towards the place where, okay, so he never goes down. Okay, so he starts his search at 0.21 and will stop once he finds the river. So with expected value problems, you always gotta like find the probabilities in terms of the points around it, right? So the probability he gets to this point is the probability he gets to this point, plus the probability he gets to this point, plus the probability he gets to that point, plus the probability he gets to this point, and then divide by 4, because each one is a 1/4 probability. But this over here is 0, because he's never going to cross that before getting to this one. Because we only care about the first time he gets here. And honestly, we really don't care if he comes from these, because then he's already reached the river, it doesn't matter. So essentially, the probability that the first spot he lands on the line is this point right here is 1/4 times this spot over here. Oh wait, let's just draw this guy 3 down so that it makes more sense. So basically, this is 1/4 of like the one below it, and then this point over here is gonna be 1/4 of this point is 1/4 of this point, and so on and so forth. But we're not looking for probability though, we're looking for the number of jumps. Well, if you know the probability, then it's easier, because then it's the expected number of jumps to here, plus a 1/4 probability times getting to here, plus 1/4 to get here. Wait, what? No. Hold up. Yeah, so basically the number of expected jumps to get to here plus 1. Wait, but there's only a 1/4 probability. This is complicated. Let's see. So clearly the number of expected jumps to get to the original location is 0, so that's fine. Then expected number to get here is basically 1/4 times the expected number from here plus 1, 1/4 times the expected number from here plus 1, and then 1/4. So you basically sum all the 4 around it, divide by 4, and then add 1. So this one right here would be 0 plus like, let's say this is P1, this is like P2, this is like P3, this is P4. So P1 is equal to P2 plus P3 plus P4 over 4 plus 1. Oh wait, well maybe just consider it on the line, right? Let's pretend that he only goes up or down, right? So we only care about him going up or back down the other way. Then the expected number of jumps to get here will basically be 1/2 to get from here and then go directly, right? So 1/2 plus, if you go the other way, then come back that way to the, what's there, 1/2 times 1/2 times 1/2, that's a 1/8 probability of him going back. So, but then multiply by 3, so plus 3/8. Wait, this is not the right way to do it, hold up. Okay, so this is P1, P1, P2, P3, let's erase this, it should be the same, yeah, it should be the same going the other way too. Wait, but the problem is that you can't go past this point right here. So what we're trying to find is how many steps we expected to take in order to get to this top point, right? So I guess we could start P1 here and then just go down from there and then have to calculate it from there. Okay, so P1 is the expected path length to get from here to the top one, like this distance here. P2 is the expected path length from here to here. P3 is from here to here, so on and so forth. So P2 it could either go 1/2 probability times 1 plus P3 plus 1/2 times 1 plus P1. So that basically means that P2 is equal to P3 plus P1 over 2 plus 1. Okay. Once you're here, the path length is 0, so P1 is just equal to P2 over 2 basically, plus 1. So we knew that moving right and moving left doesn't affect it at all. Oh, and then we also know that over here, the path length is just guaranteed equal to 1 plus P, so P1 to P24, right? Yeah, so this should be plus 1 plus P23. So essentially we need to figure out the series 0 P1, 0 P2 over, P1 is equal to P2 over 2 plus 1, and then P2 is equal to P3 over plus 1 over 2 plus 1, and then so on and so forth for all the rest. Well, if this is true, then we can plug it in here if we do that. Then this becomes P2 over 2, or P2 over 4, wait. So then this becomes P2, 3P2 over 4, and then equals P3 over 2 plus 3/4. Okay, or no, what? 3/2, which is equal to 3P2 over 2 is equal to P3 plus 3. And then we could basically just keep substituting, keep going. So that means that, so this is basically the same as 2, P1 is equal to, or wait, never mind. So then we get P2 is equal to 2/3 P3 plus 2. And if we plug this into the next one, what do we get? Then we get 2P3 over 3 is equal to 4 plus 4 over 2. Okay, so the pattern, it seems, is that we got Pi is equal to I over I plus 1 times P of I plus 1 plus I. Okay, that's kind of complicated, but that's what it seems like, right? And then if we go to the final one, then we basically get that 1 plus P23 is equal to P24, but then if we solve for P24 here, we get P23 minus 23, and then this whole thing times 24 over 23. And then if we solve for this, we basically get that 25 is equal to 1/23 P23. So that means the expected path length at P23 is going to be 23 times 25. Seems massive, but I guess that's right. Epic. So we found this path, oh no, not over 25, times 25. Yeah, that does seem massive, but it's what we got. Well, once we solve this, then we know that this is 23 times 25 plus 1. And then this over here is, we could solve for it over here. So to get 22, what would we do? We would multiply by 22 over 23, and then add 22, which would give us 22 times 26. And then 21 times 27. Oh, so it's like, what is this right here? This would be, what's 23 times 25? It's 675. So that basically means that this would be 676. Oh, so it's 24 times 24 at the bottom. Wait, no, what? 26 times 26? Hold up. No, it should be 24. Oh wait, 575. Yeah. Okay, yeah, 576 and then 24 times 24. That makes sense. Yeah, and then this one goes down by 1. This one goes up by 1 every time. So this would be 22 times 26, 21 times 27, so on and so forth. And then it'll be 1 times 48, right? Oh no, so it goes down by 23, so the other one should go up by 23, so times 47. Okay, but this only if we are going like only up and down, right? But we had to like deal with going left and right. But left and right did not change your path length, expected path length, right? It only makes it take one more, right? So there's a 1/2 chance we go left or right. So in that case, our path length just increases by 1. But in the other two cases, we know what our expected path length become. Okay, so let's see. Okay, so for this point right here, the expected path length is either 47, if it just could go wherever it wants. Like 47 seems too big. Did I do this right? I mean, I think I did it right. Yeah, I think that should be fine. Okay, so this path length, there's a 1/2 chance that it either goes up or down, in which case its path length is 47, right? So it's 1/2 times 47. However, there's another half chance that it goes right or left, right? in which case its path will be, let's say our new path, like including right and left is R1, it would be the same thing except we add 1 now, because it had another move in moving right. So this right here should equal to R1, right? Because it should have the same path length when it moves to the right. Oh, so we can do this the same for P3. So P3 should be 3 times 45, and then like it should be 1/2 times 3 times 45 plus R1 plus 1. So just plus 1, and then that is equal to R1 over 2. So this cancels out, very cool, and we get 3 times 45, 120, 135 plus 1 is 136, let's go! Oh, it's not 135 though, because each of the other ones is going to increase a ton too, right? So, we can't use 135 because it's not just the current one that's going to increase, like moving in the vertical direction. Okay, so we have the right strategy. Okay, so let's just write the equation for R1 again. It's R1 is equal to 1/2 R1 plus 1 plus, like 1/2 R0 plus R2 plus 1. Or no, we could just do the plus 1 at the end. Okay. And then we also know that, oh bro, dude, I was doing it the wrong way the whole time. Okay. And then we get, well, it's the same concept. I don't know why I limited it to the y direction first. So, okay. And then we know that R0 is simply equal to R1 over 2 or R1 plus 1. Or no, what? R1 over 2? Wait, but this, okay. So this right here is 0, because R0 should be 0. So that basically gives you that R1 is equal to R2 plus 2. Oh, sorry, it should be 1/4, because the 1/4 probability it goes up or 1/4 that it goes down. And then this will give you that R1 is equal to 1/2 R2 plus 2. Okay, that makes more sense. And then R2, we could write the same equation, is equal to 1/2 R2 plus 1/4 R1 plus R3 is equal to, plus 1, okay. And then if we plug in for R1, we get 3/8 R2 is equal to 1/4 R3 plus 3/2, right? Which is the same thing as R2 is equal to 2/3 R3 plus, what's 2/3 times 8/3? 4. And then what would the next one be? Then we get like 1/2 minus 1/6, which is going to be 1/3 R3 is equal to 1/4 R4 plus, what would it give? It would give 2. So if we multiply the denominator by 3, it's 6. So we get the similar equation, and we get that Ri is equal to I over I plus 1, Ri plus 1 plus 2 times I. Very cool. So now we do literally the same thing we did before, except now we could apply this to the 24. So basically we know that R24 is equal to, well, what is R24? R24 is equal to R24 to R24 over 3, because there's a 2/3 chance that he does that, plus a 1/3 chance that he goes to R23, and then plus 1. So if we set this equal, we get, why don't we plug for R23? So then we get R24 is equal to 2R24 over 3 plus, wait, why don't we get rid of the 3's? 3's are nasty. So then we get R24 is equal to 23 over 24, R24 plus 46 plus 3. And that gives us that R24 is equal to 24 times 49, dang, okay, very cool. And then what's R23? That's just going to be multiplied by 23 over 24 plus 46. So it'd be 23 times 51, and then it'll be 22 times 53, and then so on and so forth, until we get to 3 times what? So it went down 23 times, it should go up 46 times then. Or no, sorry, it went down 21 times, so it should go up 42. 49 plus 42 is what? 91. And hooray, we get 273 as our answer. Very cool. We did it, boys. Let's go. So basically the plan is hopefully this week or next week we will finish up this AIME, and you guys keep letting me know what other videos you guys want to do. In addition to Olympia walkthroughs, I'm probably going to do some cool coding stuff that I've been learning, so stay tuned for that, okay? But anyway, thank you guys so much for watching. As always, if you enjoyed the video, leave a like and subscribe for more. Let me know what other kinds of videos you guys want. But thank you again. See you guys next time.